So without any further ado, hi everyone. Thank you for coming into this session with us today. Welcome to the Ocean Expert Exchange, a webinar series produced by UF Thompson Earth Systems Institute's Scientists in Every Florida School program and the ANGARI Foundation. Every 2 weeks, we'll have a marine scientist with us to speak about their area of expertise, followed by this question and answer session. Scientists in Every Florida School is a free program housed within the Thompson Earth Systems Institute at the University of Florida. The CEFS program connects and builds long-term partnerships between teachers and scientists in order to bring current scientific research and big data into the classrooms in Florida and beyond. ANGARI Foundation is a nonprofit headquartered in West Palm Beach, Florida. The foundation supports and promotes marine science research and education. And many of the foundation's primary initiatives involve its 65-foot research vessel, the RV ANGARI, which completed its 34th expedition earlier this year. ANGARI also uses innovative technology, film, and other media to raise awareness and strengthen science education, and they're pleased to bring their partner scientists and resources to students, teachers, and public during this exceptional time. Today, we are joined by Joe Merchant. He is a meteorologist with the National Weather Service at the WFO location in Lubbock, Texas. He received his Bachelor of Science in Meteorology from the University of Massachusetts, Lowell, and his Master in Engineering in Space Engineering from the University of Michigan in Ann Arbor. Joe has extensive field research experience working on projects that focus on severe storms and cloud seeding. His current research focuses on shark locations and sea breeze development and began noticing unusual clusters of shark attacks that occurred off the coast of the Carolinas back in 2015. And with that, he decided to contact Dr. Greg Scommel, who is conducting an ongoing population study on great white sharks along the shores of Cape Cod. Their collaborative research has been underway for 4 years and was the inspiration behind Nat Geo's documentary Forecast Shark Attack. So without any further ado, we'd like to turn things over to Joe Merchant. Take it away.
Thank you, Stephanie. And thank you to everybody that's here watching and listening. I really appreciate the opportunity to present to you. One thing I guess that I can mention about our topic today, and then the other, the obviously the largest topic of the day being COVID-19, is that the preparation that you do before some sort of calamity strikes is real. It will ultimately be will show what the results of how well we do as a society on the other end. And so with that, I've heard a lot of analogies to preparation for a pandemic like this, to an analogy to preparing for hurricanes, because when you're preparing for a hurricane, we'll get into this and we'll get into it a little bit more later on as well as far as preparation goes. But when you're preparing for a hurricane, the weather is often really nice. It's sunny and the winds are light, and you're hearing about this really strong storm that's going to be striking in a few days, maybe even farther out, 5 days or a week out. They can be out in the ocean, over the ocean, for a long time. So the preparation is important. And then if the storm doesn't strike, of course, feel good that you were prepared and ready, and that you'll be ready for the next one. So with that, I just want to sort of express how important it is to be prepared and to sort of be ahead of the curve when it comes to whether it comes to a pandemic like this or a natural disaster. So with that, let's get to hurricane formation. And so here's a neat map of where hurricanes generally form across the planet. And you'll notice that they're closer to the equator than they are any other location. And there are reasons for that. We won't go into too much detail about why they have to be in that area, other than the fact that it's a tropical zone. It's based on temperature and direct sunlight. And so I understand that we have a lot of students from middle school to near high school in the audience today. And so one of the very fundamental things that I think about when I go into a forecast, and especially and this is really basic or fundamental for hurricanes, is warm air rises, cold air sinks. That's what we learn in science all throughout school. And for instance, think about boiling water. the bubbles start rising to the top. Well, hurricanes begin as the bubbles that begin rising to the top of our atmosphere. And so with that air rising toward the top of the atmosphere, that's the warm air rising through the colder air up above. And so once you start getting enough of that warm rising air, you start to see thunderstorms develop. And during the spring and summertime, this is the mechanism for the beginning of hurricane development. That's the first thing that you need. Next. So for hurricane formation, the things that you absolutely have to have, first and foremost, are moisture. You know, without a hurricane, if you didn't have the moisture, then in the rainfall, you wouldn't see a hurricane. You just see wind swirling, right? And so that's the same thing with a tornado as well. They're ultimately condensation funnels. And so without that condensation, without that moisture, you wouldn't even have the event occurring. So the first thing is moisture. And for hurricanes specifically, the temperature has to be right around 80 degrees or more. Obviously, warmer is higher octane fuel, so to speak. So the warmer the sea surface temperatures are, the more powerful the hurricanes. That's one aspect of what can make a really powerful hurricane. Secondly is the instability, and I just mentioned that a few minutes ago. The warm air rises, cool air sinks. And so with that mechanism in place toward the equator, that's where we start to get these big storms to develop. And this is one thing that's not always easy to wrap your head around, because here we are saying that in order for a hurricane to develop, this is the third part, in order for a hurricane to develop, which is these really fast winds at the surface, really destructive winds, we actually need weak vertical wind shear aloft. So what does that mean? Well, usually in what scientists sometimes call a static atmosphere, for the sake of this talk, we'll say it's just a normal atmosphere. The winds at the top of the troposphere, which is the environment that we experience at the surface of the planet, the winds at the top of the troposphere are faster than the winds at the surface, all the way down. So the wind speed increases as you go higher up in the atmosphere. That's why one of the reasons why planes will fly at 30,000 feet is because they have the winds. So that's why you hear the jet stream. Well, the reason why it's a jet stream is that's where jets go to fly. And so as a result, we want weak winds up there. And that doesn't really make a whole lot of sense. You know, you would think, wow, we want strong winds if we're going to have strong winds at the surface. Well, for the sake of a hurricane, it's a little bit different. And we need weak vertical wind shear at the top of our atmosphere. Next. So some of the, this is a nice visual on how this all comes together. First, on the left, you have the warmer ocean water, sea surface temperatures, and that water is evaporating into the atmosphere. And then once it gets large enough, as it starts to lift up into the upper levels of the atmosphere, it begins to actually rotate a little bit, and then you get thunderstorm development, and you get the clouds to develop. And then if you get enough thunderstorms, and this is when you start to see the hurricane begin to develop, if you get enough of this thunderstorm development, you start to get rotation at the center of it. And that would be the beginning of the eye of the hurricane developing in the middle of all of these thunderstorm complexes that are coming together. So there's a big difference, although in some ways conceptually it's okay to think about hurricanes and tornadoes as being similar, but they're really very different. Hurricanes take a long time and the conditions have to be just perfect. Not that conditions don't have to be just right for tornadoes, especially from what we saw yesterday, which I'll get into a little bit as well, about what happened across the Southeast yesterday and even in northern Florida today, or this morning. Even though it's conceptually, it's okay to think of these large masses of water rotating, but they're really quite different in how they develop. And one of the reasons for that is hurricanes are so much larger. They take days, and we'll go through the life cycle as well here in a minute. Next. So the life cycle of a typical North Atlantic hurricane, it really takes a long time for these storms to get going. And it makes sense because they're so powerful. And so first you've heard of the waves coming off of the west coast of Africa. And you'll also hear a lot of times nowadays, especially, you'll hear about the dust that is coming off of Africa. And so when that dust is in place, we actually see a suppression of hurricane development. Dust is dry, right? Dust is indicative of dry air. So if you have dust in place, you're not going to get the moisture that's necessary for these waves to develop off the west coast of Africa. And then they eventually slowly migrate south along the Bermuda High, especially at the surface. That's the Bermuda High is a very active weather pattern during the spring and summer off the east coast of of the United States in the Atlantic. And the Bermuda High is very important for the research that I'm doing with Dr. Skomel up in Massachusetts, and that I've helped conduct on the ANGARI as well. And so when that Bermuda High is in place, that's one of the favored weather patterns for these slow developing large hurricanes to develop. As you can see, by the time a wave comes off the west coast of Africa, it may be almost 2 weeks. It may almost be 2 weeks old by the time it gets to Florida. And we're going to show. I have a slide here to show how susceptible Florida is to these storms developing in its proximity. But so anyway, this just gives a really good idea of just how large and how long these storms can persist for. Next. So the peak season months of hurricane season, Florida is really in the prime position to have a direct impact from a hurricane. And so these three images attached are the likelihood of hurricanes over the last 50 years to where they hit along the the southeast and the east coast along the United States. Florida is the white dot, and as you can see, in August, they're not quite in the center of it, but they're right on the track. And then by September, they've got a bullseye right over them. And then by October, they're really, as far as land mass goes, they're the most likely location to be hit by a hurricane. So it's a place that where if you live in Florida, you really do need to pay attention to hurricane development and hurricane season, and what it is you're going to do if you believe that a hurricane is going to be impacting your local area. So it's very important that you pay attention to these things. And certainly nowadays, it's getting easier and easier to pay attention. Sometimes I think almost people start to tune it out a little bit because there is so much information. But from what I understand locally, Floridians are very in tune with hurricanes during hurricane season. So, but we do offer some mitigation suggestions toward the end of this. Next. So the size and strength of hurricanes and how we rate them. The sizes are very, very important to the strength of the storm, right? So to give you a little idea of scale, you have super typhoon. By the way, I should have mentioned that on the first slide, but typhoons and hurricanes are the exact same thing. I guess it's why we measure things in the metric system or in the English system. But anyway, hurricanes and typhoons and cyclones, they're all the same. They're all the same type of storm, and there's just different names for them across the globe. But as you can see, super typhoon Tip, which is one of the largest known hurricanes, it was massive. And tropical cyclone Tracy was very small in size, barely the size of Dallas. And wind isn't the only measure for the strength of these storms. There's also storm surge, and there's been a lot more focus on storm surge, especially with the rising waters of climate change. And this is very important for Florida. When the storm surge is really what is destructive along shorelines, not even just for the beach areas, but for the infrastructure that is along the shorelines in Florida. So you do want to, it's not just that there is a storm present. The size of the storm actually matters, and some of the stats are here on how we rate them. and how we, you know, for the wind speed. 34 knots, that's when a tropical storm is developed. And then once you get up to 64 knots, you then have a hurricane, so on and so forth up the scale. Go ahead, next. And so here it is in miles per hour. A category 1 begins at 74 miles per hour, and then all the way up to a category 5, which really there's no, we've come a long way over the past 10 or 20 years as far as making buildings and our infrastructure much more able to sustain these types of storms. But really, once you get up to category 4 and 5 type speeds, no building can be made to withstand this type of that type of wind speed and that type of damage. Now, you can do things, and building codes there are building codes out there, especially, and it probably easier for you guys to find them on your local community pages on how buildings are made around your area. But so here are the different wind speeds, and that'll be posted along with the rest of these slides. Next. So I found this map on the Hurricane Center's page, and I think it's a really good graphic of where storms have hit over the last 110 years. And as you might expect, the far southern portion of Florida is the where the X is for the target area when it comes to these storms. And it's a little more difficult, even though you're on the East Coast, up along, say, Jacksonville, because you're a little bit farther, you have that sort of inlet as you go, that subtle inlet as you go farther north along Florida. That's going to impact, the tracks of storms. But overall, storms will lift out of Tampa Bay and then brush across Jacksonville as well. So it's just the farther north you get, the less likely you are to be hit by these storms. So it makes sense that the farther south in southern Florida is where you see the most storms to have hit. Next. One of the more interesting things, and this sort of speaks to the outbreak yesterday across the Southeast, and I remember when I was looking into tornadoes across the country for a project, I saw that Florida had the third most tornadoes every year, on average, the third most tornadoes every year. And that really surprised me. I thought, I'm sorry, maybe fourth most. And that sort of surprised me because Florida isn't known for getting the type of supercell storms that impacted the Southeast. They certainly can get them. They do occur, but they're less likely to occur. And that has to do with the latitude of where a lot of population in Florida is, or I mean, the latitude of Florida and the population. People haven't been impacted by them as much. But where you get, where you have to be farther north for supercell thunderstorms to be as more powerful, and sort of the sweet spot where it is for hurricanes farther south toward the equator, the sweet spot for supercell thunderstorms and tornadoes is a little farther north than Florida. So that's one of the reasons. But the other reason is that, the reason why you have so many isn't because of those types of storms that are more commonly known for producing tornadoes. It's that the hurricanes and the tropical cyclones or tropical storms produce these tornadoes as they're coming on shore due to the friction and the high amount of spin in the atmosphere. And so these types of tornadoes across Florida during hurricanes and tropical storms, these tornadoes are very short-lived and they tend to not be as strong. They certainly can be. I wouldn't want to be in the path of one regardless, but they don't last quite as long, or they don't last as long as those types of storms that we saw yesterday across the Southeast, and they tend to not be as strong. But you do have a lot of them associated with landfall, hurricanes and storms. So that's just one sort of interesting thing that I have found about tornadoes and hurricanes specific to Florida. Next. So really important thing when it comes to whether you're talking about hurricanes or tornadoes or severe thunderstorms. what are the differences between a watch and a warning. So a watch means that forecasters are confident that the conditions are in place, and we believe that there's a good chance that whatever it is that we're forecasting has a chance to occur. So whether it's severe thunderstorms, whether or not it's tornadoes, or whether or not it's hurricanes or tropical storms. And so, for hurricanes, a hurricane watch can be placed up to 48 hours in advance. Now, 48 hours for a tornado would be incredible lead time. But, because for tornadoes, we measure success in minutes, not in hours. And so for a hurricane, especially nowadays with satellites and all sorts of remote sensing ability, we're able, to have a lot more lead time with tropical storms and hurricanes. And so with a watch, we believe that the conditions are in place for this event to occur. With a warning, that comes with quite a bit more confidence and quite a bit more preparation needed. Because if we issue a warning, we believe that the conditions are going to happen, and they're going to happen soon. Okay, next. So what can you do? And this is straight from the ready.gov website. And I plucked a few of these answers that I felt were most important, but there's actually a really good list of them on the ready.gov site. But the first thing that you can do, and as I mentioned earlier, with like COVID-19, prepare, be ahead of it. And the winds, right, as far as hurricane season goes, for Florida, the winds are calm right now, right? And you're not in imminent threat or danger. So have your plan in place. Know your risk to hurricanes. If you live in Central Florida in a somewhat elevated area, you're not at much of a risk for flooding, but you actually are at an increased risk for higher winds. So that's something that you would want to be aware of. But based on where you live, and your community should have an extensive plan, and then you can start to make your plans for evacuation, and then even practice them, and then gather the needed supplies for at least 3 days, because if you have to evacuate, or if you're trapped in your house, inundated by water, and have 3 days of supplies, and keep in mind your medication, and also don't forget the needs of your pets. Next. And that's it. So thank you very much. I really appreciate it.
Thank you, Joe. And we're excited to jump into questions. So again,
Sure.
Audience members, if you have any questions, please type them in the chat box and I will ask them on your behalf. So Joe, we're going to start with Rachel. Rachel asks, what made you want to become a meteorologist?
Well, it's funny. I'm not like your typical meteorologist in that way. I actually went through my entire 4 years of meteorology. I had been a weather observer in the military, and then so I decided to go to college for that. But I wasn't sure yet until I actually went storm chasing right after I graduated, and I saw the severe storms out in West Texas, and that's when I really wanted to become a meteorologist. Ironically, so it wasn't even until after I graduated. I wasn't sure that it was really difficult. So you really have to work hard at your math and in your science in order to get through it. Every year was more difficult than the one before, and so when I was done, I wasn't quite sure. But then when I saw the storms, it was incredible.
Doug asks, where did you go to college and what did you study?
So I went to the University of Massachusetts Lowell for my bachelor's degree, and that was, I was really excited to be able to go there and finish there. And then I actually went to the University of Michigan, and I got a master's degree in space systems engineering. I was thinking that I might go into working on satellites and remote sensing for the Earth, for storms like hurricanes. But then I decided that I really enjoyed the operational forecasting of the weather, and it's something that I've always been fascinated with, is being able to forecast and predict these storms, since I started being a meteorologist. So I've always just really enjoyed the forecasting aspect of it. So I left my space systems engineering pursuit to come back to operational meteorology.
Nathan asks, what happens when a hurricane and a tornado mix?
Well, it's not so much that they mix. It's when a tornado develops inside of in one of the outer bands of a hurricane, and that's when they tend to be, as I mentioned earlier, they tend to be not as long lived. They're going to be short, on the order of minutes, not an hour like we saw yesterday, and they'll be very quick, not quite as powerful, but they still are going to be an acceleration of the current wind speed from which it was generated. So you are going to experience, if you were to, be unfortunate enough to be in the path of one of these tornadoes, more likely than not, it would be very destructive to your house, even though it's part of the hurricane itself.
Rafa asks, are there always warnings for hurricanes?
Yes, nowadays we have a high level of confidence for the warning process. Now there's still quite a bit to be studied about how the storms strengthen, especially near land. So to the extent that to the strength and power of these storms, there's still quite a bit to be learned in how they impact land at landfall. There's a lot of science being pursued in that field. But as far as the warning process goes, from an operational meteorology, we have so many tools now, especially with the adaptation of satellites and using satellites to be able to track these storms. We feel pretty good about our ability to get the warnings out ahead of time so that people can respond effectively.
Sam asks, do hurricanes and cyclones swirl in different directions?
So that's a really good question. So yes, because of the nomenclature for the storms and where they're the parts of the world that they're named. So typhoons are going to be anticyclonic, because I believe that's in Japan. Cyclones are in the southern hemisphere, and so they're going to be cyclonic. And then we have hurricanes primarily in the northern hemisphere. I actually don't know the exact history behind why they're different names. Maybe that's something worth looking into. I'm not sure why we have the different names. I kind of wish we didn't, actually.
Cami asks, how much time do you typically spend in the field versus office? And do you enjoy one over the other?
Well, so now as a employee with the National Weather Service, I'm in an office environment almost all the time. It's when I get to go out and work on research projects occasionally that I get to do some field work, which I did on the ANGARI, which was incredible. And now there are other, prior to my time working with the Weather Service, I did a lot of field work. And field work is difficult. There's a lot of, and it's similar to the military, they say, hurry up and wait. So you're preparing and sort of in a slow, almost like preparing for the onset of a hurricane, right? You're trying to prepare ahead of time for the event to occur. And so the field work can be really exciting when the storm is occurring, obviously. I would certainly prefer to be out in the field, but I wouldn't want to do it all the time. The office work is nice too.
Sure. And we're going to wrap up with one final question from Sam. He asks, can you explain the difference between names like tropical, subtropical, extratropical, etc.?
Sure. Yeah, it has to do with the life cycle of the storm. And so, and then not only the life cycle of the storm, but the latitude of the storm. So as the storm is developing, it becomes subtropical before it becomes tropical. And so you go subtropical, then when it becomes tropical, that's when it's a tropical storm or a hurricane. And then you'll hear a lot about when a storm curves in the Atlantic and starts to head, say, toward Bermuda and into the northern Atlantic. That's when it's become extratropical in its life cycle, and it starts to look more. It loses its warm core. It's one of the the warm core, cold core is one of the thermal definitions. It's not the only definition. But as it becomes extra tropical, it loses its warm core nature and becomes more like a, say, a regular synoptic type storm that we see during the winter time, something like that.
Okay, at this point, I'm going to turn things over to Stephanie for some closing remarks.
Well, thank you, Brian. We all want to thank you very much for joining us again on the call today, and a special thanks to Joe Merchant from the National Weather Service and a division of the National Oceanic and Atmospheric Association for taking the time to talk about hurricanes with us today. Once again, our Ocean Expert Exchange will take place every other week at 3 p.m. Eastern Standard Time as part of a collaboration between ANGARI Foundation and the Scientist in Every Florida School program. You can learn more about both of our programs as well as more about NOAA and the National Weather Service via the links on your screen below. Today's presentation will be recorded, and you can find that recording along with the questions and answers from the chat box on the UF Thompson Earth Systems Institute's YouTube page, as well as the Scientist in Every Florida School website. Please be sure to register for our future events, including the upcoming April 27th edition of Ocean Expert Exchange. And with that, thank you everyone and have a great day. Bye-bye.
Thank you.